There's a newly discovered, unpatched, critical vulnerability in SGLang that turns a model server into a code execution target. And the scary part is that the attack can write in through a model file and not just through a standard HTTP request. Now, before getting into the details of the exploit, let me break down the basics of what SGLang actually does. So you probably already know that large language models consume a tremendous amount of resources. They're one of the primary reasons why GPUs, CPUs, and RAM are so expensive and so unavailable right now. And virtually every company that offers an online service is trying to shoehorn LLMs into that service because it's a hot new thing and maybe it's going to increase their profits. But to keep the number on chart going up, these large language models have to be able to scale with their customer base, and throwing more compute power at the problem is obviously too expensive. So the companies offering these AI services use inference engines like SGLang, which sits between the user and the AI model to make sure that the hardware isn't wasting time recalculating things that it has already seen. It also organizes the memory of the conversations, or KV cache, more effectively, which eats up a significant amount of VRAM when these models are running. The end result is faster processing of inputs and generation of outputs when prompts from multiple users are being thrown at a single GPU for processing. It's the classic paradigm of optimizing software in order to get the most out of the hardware that it's running on, just applied to large language models. So it's safe to say that a lot of companies running and hosting their own AI models are using engines like this, not necessarily SGLang because it is one of the newer kids on the block, but it's quickly rising in popularity and becoming a favorite for structured generation and complex agentic workflows. Even the official documentation of SGLang says that it powers large-scale production deployments, generating trillions of tokens each day across more than 400,000 GPUs worldwide. So this isn't just some obscure AI project. Now, unlike a lot of bugs or hacks that are reported with AI software, the issue here isn't the usual, someone typed a weird prompt and the model misbehaved story. This isn't another ChatGPT Dan situation. This is a server-side template injection problem that is tied to a GGUF model file carrying a malicious tokenizer chat template field. The dangerous input actually lives in the model's metadata, so the problem starts before normal prompt handling even becomes the main issue. The vulnerable feature is the re-ranking path. SGLang's re-ranking endpoint uses a cross-encoder model to re-rank documents by relevant to a query, but in the vulnerable workflow, it also renders a model-supplied chat template. That means a component that is meant to score relevance can end up acting like a code execution bridge if the templating engine is unsafe. Now, the vulnerable code path uses Jinja 2 without sandboxing instead of a lockdown environment. Now, if you're not familiar with Jinja 2, it's a pretty popular templating engine that's written in Python, used to generate dynamic HTML or other markup formats, so it's great for rendering the different outputs that you get from these models in a visually appealing way, but when you render attacker-controlled template content without proper sandboxing, the template expressions can break out of a harmless formatting and start reaching Python's internals. And this is why the server-side template injection can eventually lead to remote code execution. We actually have a public proof of concept for this exploit, which is explained pretty plainly in the README, and it comes with a fairly straightforward Python script. So the attacker creates a GGUF model with a malicious tokenizer chat template, which includes the Quen3 re-ranker trigger phrase to activate the vulnerable code path in serving rerank.py. The victim running SGLang has to download and load the malicious GGUF model, which is a binary format that's used to package LLMs. So the attacker also has to conduct a little bit of a social engineering or dependency supply chain attack in order to actually get that model onto the victim server in the first place. But with how quickly businesses like to deploy models, this might actually be easier than you think, because the operators of these services routinely download models from public repositories and are constantly experimenting with new optimized re-ranker models because of the need for efficiency with the hardware bottleneck that I explained earlier, and of course they're oftentimes just blinded by the quick money grab. So if a hacker uploads a model called Quen3 optimized re-ranker.gguf to a model hub like Hugging Face, it might not receive the amount of scrutiny that you'd expect, especially towards the chat templates, which are usually thought of to be pretty harmless. Now, in most cases, once the malicious code is loaded, the attacker actually doesn't need any further interaction with the service in order to compromise it. The malicious payload sits dormant inside of the chat template, and when the service processes a request through the re-ranker pipeline, SGLang renders that template, and that is when the execution happens. And it happens because this re-ranker models are expecting formatted input. The servers that are running these programs don't just pass raw text into the model, it gets formatted with that chat template defined inside the model's tokenizer config. So the exploit abuses this by embedding a malicious Jinja 2 template inside of that chat template field. So when any request hits the re-rank path, SGLang reads the chat template and renders it with the unsandboxed Jinja 2 environment, which executes arbitrary Python code on the server that can lead to a takeover of the host that's offering this AI service. And then from there, the possibilities are endless. If you own the server that's offering this service to paying customers, you can just deploy attacks against the users of the service. You can exfiltrate sensitive data about them. You can make lateral movements into other systems that the compromised server has access to, or you could just do a good old denial of service attack. So since the vulnerability requires the victim to download a compromised model first, the obvious solution here is to properly vet the models that you're downloading and that you're going to use in your AI service. Like obviously, if you download malware, there's a good chance that it can take over your system. And this is really where one of the big issues are because, again, so many businesses are looking to use AI in some type of way. A lot of them want to use their own self-hosted models because ChatGPT and Claude's APIs are getting more expensive by the day. Plus, they have all of these safety rails applied to them that make it less capable at performing the task you want compared to a self-hosted AI, even if it has fewer parameters. And it also makes sense from a business standpoint if you are able to get your hands on the graphics cards, because the AI boom has caused those components in particular to retain their value for a lot longer than they used to, compared to back when NVIDIA was just associated as a gaming company. So if you can invest in the hardware to run your own local models, you're actually building equity compared to a ChatGPT subscription that doesn't have any resale value. If your business is actually successful and you get a lot of customers, then you can scale for a lot cheaper than paying more for these remote APIs. And of course, if you're running your AI models locally in-house, you have much better data security, assuming your servers aren't vulnerable to attacks like this, than you do compared to using OpenAI's service, which mines your data and sells it to the government. But design-wise, a lot of this could just be avoided by using sandboxed Jinja templates. The proof of concept exploit literally requires the default unsandboxed Jinja environment in order to work. Just like CVE 2024-34-35-9, codenamed Llama Drama, which is another critical RCE flaw in the Llama CPP Python package, which actually has now been patched. But unfortunately, it doesn't look like SGLang has patched this particular vulnerability yet, but that extra security step of manually replacing the default Jinja 2 environment with Jinja 2 Sandbox in the framework would prevent exposing dangerous objects into the template context. So make sure that your services are as secure as possible before just rushing to deployment. That's the main thing to keep in mind, especially in this vibe-coded era where everybody wants to deploy quickly. If you enjoyed this video, please like and share it to hack the algorithm, and check out my online store, based.win, where you can buy my awesome merch and accessories for your phone or laptop. 10% store-wide discount when you pay with Monero XMR at checkout. Have a great rest of your day.